Welcome back to the session 12 of the differential equation. In this session, we like to discuss about orthogonal trajectories. The orthogonal trajectories is just like an applications of a differential equation. Before going to discuss about orthogonal trajectories, I like to discuss about family of curves that already we discussed in some sessions. Family of curves means we are defining the curves that are the functions involving x, f of x, y, c equal to 0. That means is a mathematical expression containing the variable x, y and c. Here x is a independent variable, y is the dependent variable and c is a constant. Here we are treating c as a arbitrary constant. Arbitrary constant means it will treat like a variable. Simply we can write as f of x plus x y c equal to x plus y plus c, which is equal to 0. This is a family of curves. Here x is a independent variable, y is a dependent variable and c is an arbitrary constant. If c is a single constant, we can say that this is a straight line. This is a straight line. This is a straight line. But if we are treating f x plus y plus c equal to 0, we are treating c as a arbitrary constant, that will be it will be do like a variable. It will act like a variable. In this case, we can say that these are the family of straight lines. That is, we know that generally we have an equation of line is equal to y is equal to mx plus c are the set of straight lines passing through. It will crosses the y axis at the point C as the y intercept and with the slope m. And here like that we have the set of straight line like that, y is equal to minus x plus minus c, minus x minus c is there. These are the set of lines. Based on the value of c, we will have we can decide that as a y intercept, and here it is as a negative 1 is there. So, with the negative slope we will get a, if we are treating c as a variable, we will get a bunch of lines, a system of lines, collection of lines that are the family of curves. See, while discussing family, we discussed here straight lines are there, and similarly we can have f of x y c equal to x square plus y square minus c square equal to 0. See, I am taking x square plus y square minus c square equal to 0. See, I am taking c square to be here. What will happen? X square plus y square equal to c square. That means we know from very our basic classes in high school classes we studied about x square plus y square equal to c square is a geometric structure, that is circles centered at origin, circles centered at origin with the radius c, with the radius c. We are taking c as a variable. So, we will have that means she can vary, it will act like a variable. So, which means we will have a collection of all circles, we will have a collection of circles that we can say that these are the concentric circles. We will have a collection of circles which are the concentric circles are there. So, we can say that this is a family of circles, this is a family of circles. Similarly, we can have another collection of lines f of x y c is equal to y minus c x square equal to 0. That means y minus c x square equal to 0. That means y is equal to c x square, y is equal to c x square. See, we are able to understand that y is equal to c x square be the collection of all parabolas, be the collection of all parabolas. So, we can say that y is equal to c x square be collection of all parabolas which is symmetric about y axis. this is x axis and as well as this is y axis, depends on the value of c. Y is equal to x square will be here, we will have parabola like this, and similarly if c is negative we will have parabola like this, and we will have many parabolas, that is the collection of parabolas is a system of family of curves will exist there. So, this is y is equal to c x square. See, before going to discussing about this orthogonal trajectory, why I am discussing the family of curves. Before going to orthogonal trajectory itself, I like to discuss about the differential equation corresponding to a family of lines. See, here we have a family of circles are here. Here you have family of circles are there. I am taking x square plus y square equal to c square, and I am differentiating both sides. I am taking this as equation number 1. I am differentiating 1 both sides, differentiating 1 with respect to x. See what will happen. This is x square, derivative of x square is 2x, and the derivative of y square is 2y into derivative of y, that is dy by dx, equal to, here even though it is a variable, because of arbitrary constant we are treating c as a constant, therefore derivative of c is equal to 0. So, 2 is common, we can take out and remove from here. So, we will have from here x plus y into dy by dx equal to 0. I am taking this x to be opposite side, plus x will comes to minus x, y dy by dx is equal to minus x. See what will happen, y, I am taking y to be here into denominator, therefore dy by dx equal to minus x by y, dy by dx equal to minus x by y. I am treating this as a equation A. This equation A is a differential equation. This equation A, the differential equation, we generate this differential equation from the equation 1. Equation 1 is the set of all straight lines, that is the family of all family of circle, concentric circles. So, that means this equation A is a differential equation corresponding to family of circles, See, as we done previous itself, I am taking this is to be here, I can separate this as y dy by dx is equal to x. I am taking minus x, dx to be here, y dy is equal to minus x dx. So, as we discussed earlier, this is a separable method. In left side the term containing y only, and the right side the term containing x only. So, easily we can integrate and we will have a solution from here. While integrating on both sides, what will happen? Integral of y dy, this is y square by 2 and this is equal to minus x square by 2 plus c is there. See, from here we can understand that y square by 2 minus x square by 2, y square by 2, I am taking minus x square by 2 to left side, what will happen? This is x square by 2 equal to c. So, we can rewrite this as x square plus y square is equal to 2c, x square by 2 plus x square plus y square equal to 2c. So, I am taking 2c as another c, x square plus y square, x square plus y square equal to c. So, as we from where we start from x square plus y square equal to c square, and after differentiating one we will have a differential equation dy by dx equal to minus x by y. And while solving this differential equation as a method of variable separable, again we will get a solution as circle centered at origin with radius. Here this c we can rewrite this c may be as another c square, it depends on the different value we can have c square or c dash square. So, because of this is a constant we can write like that. So, because this is an arbitrary constant we again arrives to the equation 1. So, we can generate a differential equation from 1 we will have a differential equation corresponding to 1. While solving that differential equation, we will again arrive to this family of straight lines. So, similarly, you can find out the differential equation corresponding to family of parabolas and which is symmetric about y axis. Why the family how the family of parabolas which is symmetric about y axis, y is equal to c x square is there. We know that the family of parabolas like this, we already shown it is here. This will come like this. Family of parabolas will come like that, and what will happen after differentiating this family of parabolas? While differentiating on both sides, we will have dy by dx equal to c into derivative of x is 2x is there. Say from the equation of parabola, we will have c is equal to y by x square. Replace the value of c here. What will happen? Here dy by dx is equal to, instead of c we can replace the value as y by x square. So, this is y by x square into 2x is there. We can cancel x and x from here. So, after all we will have dy by dx is equal to 2y by x. This is a differential equation corresponding to the collection of all parabolas which is symmetric about y axis. While solving this differential equation, if you solve this differential equation b, you will have, if you solve the differential equation b, you will get the equation of the parabola. So, this is the connection between the equation of the family of curves as well as their corresponding differential equation. From there you can generate a differential equation. While solving that differential equation, again you will arrive to same family of curves as a solution of the differential equation. See, our main discussion is about orthogonal trajectories. Orthogonal trajectories, before going to orthogonal trajectories, just I like to define what is orthogonal trajectory, what is OT. Orthogonal trajectories are the family of curves. We already discussed about the family of curves, are the set of all equations of the form f of x y c is equal to 0. I am taking this as a family of curves. This family of curves may exist a orthogonal trajectory that is perpendicular to, orthogonal to, perpendicular or orthogonal to all the members of 1, all the family of curves of 1. See, I am writing like this. I am taking this is x axis and this is y axis, and I am taking a bunch of straight lines, family of straight lines. This family of straight lines are the f of, I am treating this as f of x y c equal to 0. See, what will happen is that all the straight line, collection of all straight line which are parallel to x axis. So, we have to find out the orthogonal trajectory of this f of x y c equal to 0. That means, we have to find out the orthogonal trajectories of family of the straight line which are parallel to x axis. Simply we can say that which are the curves or lines which is perpendicular orthogonal to these lines. Simply we can draw a line like this which will make an angle 90 degree with each line. So, we can say that. What about this line? This line is a straight line parallel to y axis. So, we can say that the orthogonal trajectories of the family of straight line parallel to x axis are the lines which is parallel to y axis. Simply we can say that we can draw infinite number of lines which will crosses the family of straight line parallel to x axis with the angle 90 degree. So, we can say that the set of all the family of straight line parallel to y axis are the orthogonal trajectories of the family of straight line which is parallel to x axis. So, our aim to find the orthogonal trajectory. How we will find our orthogonal trajectory? See, Orthogonal trajectory means we already discussed it is that the family of curves which is perpendicular to orthogonal to f of x y c is equal to 0. So, actually we have a family of curves are there f of x y c is equal to 0. So, we will differentiate to find orthogonal trajectory. How we will find the orthogonal trajectories? We have given that f of x y is equal to 0, and on step 1 we will differentiate. In step 1 we will differentiate 1 with respect to x. What will happen? We will have a differential equation corresponding to the family of curves 1. We get a differential equation, that is ordinary differential equation corresponding to 1. We will have a differential equation corresponding to 1. After finding the differential equation corresponding to 1, because of that is a differential equation, we are differentiating only at once. It is a ordinary differential equation, that should be an ODE, ordinary differential equation of order 1. That means we will have a first order differential equation. That is why definitely there exists a term of y dash is there. Now, we will move to our step 2. In step 2, what we will do that we will replace y by replace y dash by minus 1 by y dash. Why we are replacing y dash as minus 1 by y dash? See, we have in straight lines we studied it is that this is a straight line have a slope m. I am taking slope as m1, and we saw that we have that this is another straight line L2, this is I am taking as L1, this is L2. L2 has a slope m2, and if they are perpendicular, that means they create angle 90 degree. We can say that product of their slopes m1 into m2 is equal to minus 1. We already know about this, and as well as we are treating y dash in most of the application as slope of the line or slope of the tangent line, and we are taking we have y dash into minus 1 by y dash is equal to minus 1. Actually, we need to find out a curve which is orthogonal to given family of curves. That is why we are differentiating, we will have a differential equation corresponding to 1, we are changing y dash into minus 1 by y dash. That means we will have a new differential equation, first order ordinary differential equation, which is corresponding to, while solving that differential equation we will have a curves or lines or family of curves which is orthogonal to given family of curves. So, we are replacing y dash as minus 1 by y dash, and after in the last step we will change as just arranging. Most of the case maybe we are able to make as a variable separable. If we are able to make as variable separable, or we can solve the differential equation in any of the method as we discussed earlier. So, just integrating the new differential equation, the new differential equation, we will have a orthogonal trajectory. So, we will have a orthogonal trajectory of given family of curves f of x y c is equal to 0. See, what we will do is that we have given in our question as family of curves are there. We just differentiate that family of curves, and we will have a ordinary differential equation corresponding to 1 and which is of order 1. Therefore, definitely it contains y dash or dy by dx, and after getting this differential equation we just replace y dash as minus 1 by y dash, because y dash into minus 1 by y dash is equal to minus 1. So, now we have got a new differential equation. That new differential equation is a differential equation corresponding to the orthogonal trajectory. While solving that new differential equation, solving means we are integrating. While solving that new differential equation, we will have a new family of curves which are orthogonal to the family of curves 1. That is what is called the orthogonal trajectory of given family of curves. So, we can do some example to explain the orthogonal trajectory. See example 1, an example 1, find orthogonal trajectories of family of curves, find orthogonal trajectories of the family of the curves x square plus y square is equal to c square. Say I am taking x square plus y square is equal to c square as family of curves as equation number 1. See, we are familiar about this family of curves, we already discussed about it. This is a set of family of concentric circle centered at origin with a radius c. So, in our step 1 we will differentiate, step 1 differentiate 1 with respect to x, with respect to x. What will happen? Here we will have 2 x is there and derivative of 2 y square is 2 y into derivative of y, that is y dash is equal to, we are treating c square as a constant, therefore, that is equal to 0. We have 2 is common, therefore, x plus y dash is equal to 0. I am taking 2 to be out and I am taking to right side, 0 by 2 will be again equal to 0. Now, this is okay, this is I am taking 2, this is a differential equation corresponding to equation 1. See, actually we have to find out a differential equation corresponding to, actually we need to find out a differential equation corresponding to family of curves which is orthogonal to equation 1. So, I am just coming to the step 2. On step 2 we will replace y dash by minus 1 by y dash. So, equation 2 becomes x have no change and plus y is there and just replacing y dash as minus 1 by y dash, y dash as minus 1 by y dash, minus 1 by y dash equal to 0. So, taking this is to be opposite side. So, we will have y into minus 1 by y divided by y dash into 1 by y dash is equal to x. I am taking this is to be opposite side, for the convenience I wrote like this. See, this is 1 by y dash is equal to x divided by, I am taking this y to be here. So, x divided by y. Therefore, y dash we can take reciprocal on both sides. See what will happen, y dash is equal to y by x. Y dash means dy by dx, dy by dx is equal to y by x. Now, we have this is a differential equation. So, y dash as equal to y by x. This is a differential equation corresponding to, we have by changing y dash as minus 1 by y dash. So, we will have a, while solving this differential equation which is a family of curves corresponding to a new differential equation, that new differential equation is formed by changing y dash as minus 1 by y dash. That set of family of curves are the orthogonal trajectories of given family of curves 1. So, I am taking y to be here and dx to be here. So, dy divided by y is equal to dx divided by x. Say what will happen, it is that integrating the step 3, the last step is the integrating this one. I am taking this as equation 3 integrating 3, integrating 3. While integrating 3 we will have, while integrating 3 we will have integral of dy by y is equal to integral of dx by x plus c. So, integral of dy by y, that is log y, is equal to integral of dx by x log x. I am taking constant as a log c. So, we will have log y is equal to log x plus log c as a log of cx. So, taking exponential on both sides, we can write this as y is equal to cx, and this is the family of curves which is orthogonal to 1. These are the orthogonal trajectories of family of curves 1. See, similarly we can say that this is equal to y is equal to cx. That means the set of all straight line passing through origin with the slope c. We are treating c as an arbitrary constant, therefore, value of c will changes. So, how the figure will come? See, we will have the family of curves as the concentric circle. This is our x axis and this is our y axis, and we will have the family of circles like this, and these are the given equation 1, and we will have orthogonal trajectories are the family of straight lines passing through origin. You can have infinite number of family of curves. We can have infinite number of family of curves, can find from here, and these are the orthogonal trajectories. Even your x axis and y axis are also the orthogonal trajectories of the family of circles. Orthogonal trajectories of these dashed lines are the orthogonal trajectories of given family of circles. So, we can say that these all lines are the straight line passing through origin are the orthogonal trajectories of equation number 1. So, I will move to the next example. Example 2. Find orthogonal trajectories of families of curves of y is equal to cx square. The family of y is equal to cx square. What about y is equal to cx square? Are the family of parabolas which are symmetric about y axis, So, I am taking this as equation number 1. As we did earlier, what we will do on step 1? We will differentiate. In step 1, we differentiate 1 with respect to x. So, we will have y is equal to dy by dx is equal to, we are taking this x as a 2cx. Now, this is a differential equation corresponding to 1. From 1, we will have the value of c is equal to y by x square. I am replacing the value to be here. See what will happen, dy by dx is equal to 2, instead of c we replace y by x square, x is there. So, we can remove one x and x from here. So, we will have y dash dy by dx equal to 2 y by x. Now, our step 1 is over, where we have got a new differential equation. This is a differential equation. This equation number 2 is a differential equation corresponding to equation 1. Now, we can move to the next step. On step 2, we replace y dash as minus 1 by y dash, See how, what will happen for our differential equation 2. So, y dash as minus 1 by y dash is equal to 2 into y by x. There is no change for the right side. So, we can write this as minus 1 by y dash. We can take the reciprocal on both sides. So, we will have minus y dash is equal to 1 by 2 x by y, 1 by 2 x by y. See, I am taking giving this is equal to dy by dx, dy by dx is equal to minus 1 by 2 x by y is there. See, I am taking this 2 to be here, therefore, we will have 2, I am taking y to be here 2y dy is equal to, I am taking dx to be here minus x dx. Now, this is a differential equation. We got this differential equation, by changing y dash as minus 1 by y dash. While solving this differential equation, we will get a family of curves which are orthogonal to family of parabolas which is symmetric about y axis. So, I am integrating, I am taking this as equation number 3, integrate 3. Integrating 3. So, we will have integral of 2y dy is equal to minus integral of x dx, minus integral of x dx. 2 y square by 2 equal to minus x square by 2 plus c. So, this is equal to y square x square by 2, I am taking x square by 2 to be here, plus y square is equal to c is there, instead of c I am replacing as 1 as a particular constant, and or otherwise we can have x square by c 2c, or otherwise we can write this as, while writing 1 instead of 1 as c, x square divided by 2c plus y square by c is equal to 1. See, what about this figure? This is the geometrical formula of the ellipses with the major axis as 2c and minor axis as c. So, we will have this is are the orthogonal trajectories of equation 1. Equation 4, this is the orthogonal trajectories of 1 are the family of concentric ellipses. It will come like this. The ellipses are the orthogonal trajectories of families of parabolas. So, these are the orthogonal trajectories. See, this is just an applications of differential equation, and we can have many examples related to orthogonal trajectories. I will come to you with more examples on the next session. Thank you for watching this videos. Thank you very much.